Hello everyone and welcome to our second coding grace video. I'm Vicky and right beside me is Mick, and as you can see we are trying something a little bit different from the last time. So this is part 2 of Raspberry Pi Pico shown by Mick, and we are going to continue on from that, so over to Mick.
So what we're looking at is on this picture here, you can see all the green GPIO pins, GP0 through to GP20 something. And what we're doing is we're going to be looking at this little circuit here, which I'll talk through in a second. Let me just position it very slightly. So what this is basically doing is just simply taking a button, a little clicky button, and responding to that. So GPIO lets you do input and outputs. So what we see here, if we match it up to the other picture, is I plug something into GP0 or pin 1, depending how you look at it. And I've also plugged in something into the 3 volt output. So in order to make any circuit work, you have to kind of connect around. And so what I'm doing is I'm actually taking the 3 volt output, which goes through to here, then goes into that pin on the button. And then when you click, that connects the circuit and brings it around to here and back around to the GPIO pin.
And for those who are not familiar with electronics, what's that white thing with all the holes on it?
So this thing is sitting on, okay, I'll talk through this a bit. This is a breadboard. It's a very handy way to prototype electronics. I really recommend getting one. They're very cheap. You can get one or two very easily. And the Pi itself, the Pico, I've soldered on a bunch of pins onto it. So you can buy them pre-soldered, although it's not a bad beginning soldering project. You certainly get a bit of practice in soldering on 40 pins. And then I'm using these little jumper cables, which are, again, super handy. You can usually buy a kit of like a breadboard and a bunch of cables and buttons and all sorts of things reasonably cheaply. They're reasonably easy to get a hold of. Most places who sell the Pico will sell something. And so the idea of the jumper cable is they're very easy just to plug in, and you can just connect up different parts of the breadboard. So it's very handy for prototyping and experimenting. And just a couple of things on the breadboard. This particular breadboard, the way it's arranged, you'll see these two pins here these two rows are slightly differentiated. They've got a red stripe and a black stripe. That's usually where you connect in the positive and the ground power. So effectively the power. So typically you bring power into here and then connect it into different parts where you need power from these two power rails. Then the rest of the pins, you can see they're all numbered, and they're going to go across this way, and they're divided into little clusters. So say for number 23, I think it is there, you can see there's like 6 pins, and then there's a gap, another 6 pins. And so there's a line going across, all connected together, and then a gap, and then another line connected together. So you can see this button straddles that gap. And so I have this one connected here, and you can see it's sort of lined up with the pin on the button there, and similarly over here. So these connect around to form a circuit. So power will flow from this positive pin here, which you can see here is number 37. So you can see the 3 volts, 36 is a 3 volt output. So it's handy for connecting up circuits. And then that flows into this little cable, goes into the button, and then goes back around into the GPIO pin. So GPIO pins can take power in or out. They can basically send power or they can receive power. And depending on the way you configure them, they can do different other things, but we're just going to focus in on power in and power out.
Okay, so powering the button, well, you're powering the Pico with the USB cable. So how do you make the button light up when you press the button? So there's a bit of code that goes with it, right?
Yeah, so the button itself won't light up in this one. You can get buttons that light up, but this one doesn't, unfortunately. It's just a boring, clicky little button. So what you do have, though, on the Pico, which is very handy, is a tiny little LED.
Yeah, that's what I meant. When you press the button, the little LED lights up.
You can see it there by the USB. And so what we can do is we can write a bit of code to do this. So I've got this plugged in. You can see a little USB cable here. This is going into a Pi 400. So if I switch over to that desktop, you'll see I have a little Raspberry Pi 400 already set up to go. And that basically, if I just put this on for a second. So that's connected through, and I have a few different things going on, but I'm going to walk through how I figured out how to connect to this from the day one. So the first thing I do is I went to the kind of hardware and products, and I went to the Pico, And then down here is a little get started. And then they have a bunch of guides. Since I'm using MicroPython, I use the MicroPython guide. And I've done this already, but when you plug in the Pico, it appears as a USB disk. So what you do is you download the MicroPython itself, and then plug it in, hit that button, and that makes it into a special mode called a bootloader. Especially this is a special mode for loading on new programs. Drop in the file, it writes it to the USB, and then it will reboot into MicroPython. So to connect into MicroPython, as a helpful thing, when the Pico's plugged in, it starts up in MicroPython, but obviously you can't see anything. There's no screen on it. So one thing they do is they'll make the USB act as a serial port, which is a way to connect into it, which I'll jump over to now, which hopefully we'll talk about this. My one minor gripe with the docs, they're very good, but they are giant PDFs, and so you can be scrolling around quite a bit trying to find the bits you want. So there we go. So MicroPython, as I say, listens on serial, and serial ports, these are something that's been around pretty much from day one of computing almost. Well, probably not that old, but close to. They're a very simple way to transmit data backwards and forwards, and the name kind of implies what they are. They're serial data, so it's effectively a single line for all intents and purposes that's flipped high and low, and data just gets sent by flipping it high and low in a pattern. And basically you can use these tools like Minicom to connect over this. So the OSs like Linux automatically expose the serial port as a way to connect to it. We can use different editors, but we'll use Thonny, partially because that's the one we can use, but also because that's the one the docs use, so that makes life easier. So to fire up Thonny, we'll go to programming, go to Thonny. Now my one is already set up for MicroPython, so it connects straight in. If it's not doing that, make sure that you just click here and you click MicroPython here, and it should connect in automatically. So we'll get the same interpreter, the same REPL, so I can do print hello, and it'll print out. It's actually a slightly nicer interface. And so what we'll do is we'll put the code in. I have one written already, but I'll see if I can do this from memory. Machine import pin, import time, and then I go while true. Oop, and I need to create the pins first. Let's go back up and do that. So LED equals pin 25 pin dot out. Button equals pin 0 pin dot in, and I think it was pin dot pull down. Oh, not completing. Let's do this from memory. Pin 0, and then so if button dot value, so if that's 1, we'll do LED dot high, else LED dot low, and then we'll add a teeny tiny sleep just in case. And we'll save this. Now this should run this. If I run this now, I can run this on the Pico, and I have to save this, so I'll call this main.py. So main.py will be run every time the Pico starts up. So I move this over, then do this. With a bit of luck, you can see the LED turns on. So you can see that's great. And then if I stop this, it will jump back into the REPL, but then I can run it again. You can see it still goes. If I stop it, it'll stop working. You can see it's not responding anymore, but we'd have the REPL. So the idea is it's either going to be running your program or it's going to be in the REPL. And just to prove this is now saved, I will close this, move this out of the way. Boink. Switch back to here, just because it looks cooler. And I will plug this out. It's plugged out, it's powered off. So let's see if it saved it. And now click, and it's saved. So now this is actually totally standalone. It just needs USB for power, and this is now fully functioning standalone GPIO button LED blinker. There we go.
Oh, brilliant. So so yeah, do follow the docs, that PDF file, as so it kind of gives you the kind of basic foundation on connecting it up.
And they give a lot of examples. In fact, there are better I'm going to air quote this, better ways to do this. For example, the reason I put the sleep in is quite often you want to be sort of doing other things in your code and kind of giving time for the CPU to do other stuff. But a better way is to use what's called interrupts, and they give examples of that. So the idea is that you can tell the Pico that when something happens on that pin, it will trigger what's called an interrupt and stop whatever else is happening and jump to your code and run that and then jump back again. And this is very useful for reacting to hardware events.
So as far as this video, I think we'll stop there.
Yep.
And so that was actually quite a bit of work just to get a button to light up an LED. So I suppose once you get used to it, you can just wire everything up and do more complicated stuff, and you start building out all the bits and pieces.
Yep. So the principle stays the same, but the steps get more complicated over time. And so, but the idea is you'll essentially be making more complicated code like that.
So, thank you again for taking us through the Pico. Hopefully we'll add kind of more little projects with the Pico and show people what you can do. And if you like this video, do hit that like button and subscribe. And a huge thank you to Michael for stepping us through. And yeah, so let's just say bye-bye.
Okay, bye-bye.